Hello dear students, welcome to a new session. In this session we'll be learning about special cases of parallelogram. The first figure is the rectangle. The rectangle is a parallelogram with a right angle. Let's go and see the properties of a rectangle. The first property, all angles are equal in measure and the measure of each one of them is 90 degrees. The two diagonals are equal and bisect each other. The second special case is the rhombus. The rhombus is a parallelogram with two adjacent sides equal in length. Let's now go to the properties of a rhombus. In the rhombus, all sides are equal in length, the diagonals are perpendicular to each other, and they also bisect the vertex. The third figure we have is the square. The square is a rhombus with a right angle. The square is a rectangle with two adjacent sides equal in length. Let's now move on to see some properties of a square. All sides are equal in length, all angles are equal in measure, and the measure of each one is 90 degrees. The two diagonals of the square are equal in length, perpendicular to each other, and also bisect the vertex, and also make angle of measure 45 degrees with the side. Let's go and see the first exercise. Choose the correct answer. The two diagonals of a rectangle are excellent. They are equal in length. Question 2. The two diagonals of a rhombus are good job, are perpendicular and not equal in length. The two diagonals of a square are excellent, are perpendicular and equal in length. Question 4. If two adjacent sides are equal in length in a parallelogram, then the parallelogram is a rhombus. Good job. Question 5. If ABCD is a rectangle in which AC is 5 centimeters, what is the length of BD? As you can see here, AC, if you draw the rectangle, AC is a diagonal. And we know that in the rectangle, the diagonals are equal. So BD, the other diagonal, is also equal to AC. It's equal to 5. Question 6. If ABCD is a square, then the measure of angle CAB is equal to what degrees? If you draw this square, and you name it as ABCD, so here is angle CAB. So this angle we know that is 45 degrees. Question 7. If ABCD is a parallelogram in which the measure of angle A is equal to the measure of angle B, and here angles A and B are two angles beside each other, then ABCD is a rectangle. Exercise number 2. In the figure, if ABCD is a parallelogram where E belongs to CB such that BC is equal to BE and DE is equal to AB, then the question wants me to prove that AEBD is a rectangle. Since ABCD is a parallelogram, therefore AD is equal to BC. Since BC is equal to BE, therefore AD is equal to BE. And let's call this number 1. Since AD is parallel to BC, therefore AD is parallel to BE. Let's call this number 2. From 1 and 2, therefore AEBD is a parallelogram. Then we prove that it is a parallelogram. Since AB is equal to DE as two diagonals, therefore AEBD is a rectangle. Let's now go to exercise number 3. In the figure at right, if ABCD is a rhombus, where BD segment is a diagonal in it, and the measure of angle ABD is 62 degrees, the question wants me to find the measure of angle A. Since ABCD is a rhombus, therefore the diagonals bisect the vertex, which is the angle ABC. Therefore, the measure of angle DBC is equal the measure of angle ABD, which is equal to 62 degrees. Therefore, the measure of angle ABC is 2 times 62, which is 124 degrees. Therefore, the measure of angle A is 180 minus 124, which is 56 degrees. Exercise number 4. In this figure, if ABCD is a square, its two diagonals intersect at M, and EF belongs to AC, such that AE is equal to CF. The question wants me to prove that EBFD is a rhombus. Since ABCD is a square, therefore AC is perpendicular to BD, and also AC is equal to BD. Let's call this number 1. Since AE is equal to CF, where DB is perpendicular to EF, and call these number 2, if you subtract 2 from 1, you will find out that ME is equal to MF. Therefore, EBFD is a rhombus. Since ABCD is a square, therefore AC is perpendicular to BD, and also AC is equal to BD. Let's call this number 1. Since AE is equal to CF, and we're going to call this number 2, where DB is perpendicular to EF, if you subtract 2 from 1, we will get that ME is equal to MF. Therefore, EBFD is a rhombus. Now let's go to the evaluation part. Dear students, as I always remind you, when we come to the evaluation, pause the video, try to answer the questions yourself. After that, play the video again to check your answer. In this figure, ABCD is a rectangle, while OBCH is a parallelogram. The question wants me to prove that AO is equal to HD. Since ABCD is a rectangle, therefore DA is parallel to CB, and also DA is equal to CB. Let's call this number 1. Since OBCH is a parallelogram, therefore HO is equal to CB, and call this number 2. From 1 and 2, we can get that DA is equal to HO. By subtracting HA from both sides, then AO is equal to DH. Then AO is equal to HD. Since ABCD is a rectangle, therefore DA is parallel to CB, and also DA is equal to CB. Let's call this number 1. Since OBCH is a parallelogram, therefore HO is equal to CB. Let's call this number 2. Obviously, from 1 and 2, we can easily prove that DA is equal to HO. By subtracting HA from both sides, therefore AO is equal to HD. And now, dear students, we reached the end of our session. Thank you and good luck.